So we are done with chapter 1 revision. So please revise. Okay, you have just roughly 2 weeks for the exam. So we will begin the revision for chapter 2 right now. And before that, I will show you some. A few weeks ago, we played something called as anagram, right?
Yes, sir.
Do you know what the anagram is? Like jumble word? Yes?
Yes, sir.
So I will show you one word. Try to guess what that word is. Okay?
Yes, sir.
Okay, so the word is whisper.
Pressure.
Is it sure? Are you sure?
Yes, sir.
Can you confirm?
Pressure.
Okay. So 2 is 1s. Okay, it was easy, right?
Yes, sir.
Alright. So pressure. So today we will be learning about fluid pressure and or pressure in fluids. Okay, we have already learned. So I think it must be easy right for now. Yes. So let us recollect. Okay. Alright. So we have already done with anagram. So we will look at terminology related to fluid mechanics. Your sir might have also explained this last time. And we look at one simulation. Did sir do any simulation before?
No, sir.
Okay, so I will show you the simulation, okay? And then we will derive mathematical expression with simulation and through maths also, 2 ways of deriving, okay? And then we will have some question answer session. Alright?
Yes, sir.
So before that, okay. So these are the words that you need to know. So you know about pressure. I think you already know what is depth, right?
Yes.
And density. So this is how we represent density, okay? And what is this word?
Rho.
What is the name of this letter? Rho. Okay. So while in exam, so don't write P and rho same, okay? So you write P like this and rho is written something like this, okay? Curved P, okay? So don't make your P and rho look same, right? And then we have something called as thrust. You already know what a thrust is, right?
Yes.
Up thrust. And then you know what a fluid is. What is a fluid?
Anything matter that can flow.
Like I saw your slide, so I've written anything matter. So it is any matter that can flow, okay? Anything matter means the sentence isn't correct. So any matter that can flow. So can you name the matter that can flow? So how many states of matter are there?
3.
No, now it is updated. We have
5.
Okay. And what are from those? Okay, so let's assume only 3 right now. So from those 3, what are the fluids?
Liquid. Solid liquid, yes.
No. One is liquid, another one is
Gas.
gas. Okay, so gas and liquids are called fluids. Okay, not just liquids. Gas is also called as fluids. So anything that can flow is fluid. So gas can also flow. So liquid and gas is called as fluids. Okay, and then you know temperature, right?
Yes.
What is temperature?
Heat energy difference of the body.
The heat contained in the body. So there are 3 different ways or 3 units of temperature. We will learn in next class. Okay, that is your chapter 3. So let's look at simulation before. Okay, before the simulation, I think you need to know about this. I'm not deriving because you have already learned. So the spoilers is already being done. Okay. So how do we represent pressure? So you know that pressure is
Force.
force divided by
Acceleration.
acceleration. No, it's not
Area.
acceleration.
Area.
Area. So in physics, we write acceleration in small letter a. Okay. So whenever you see a capital letter A,
Area.
it is area. Okay? Like in maths, you must have written small a. So that, but in physics, if you see bigger a, area and small a is acceleration. Okay. So how is force related to pressure? So greater the force,
More
greater is the pressure. Greater the area,
less
less the pressure. Okay, because pressure is inversely proportional to area and pressure is directly proportional to force. Okay. So numerator, same line, it means directly proportional. Below something, it means inversely proportional. Okay. And so let's say there might be questions like, if you walk on one leg and on both the legs, which one will be easier for you to walk?
Both
Both legs. Why?
Because the best food.
More area.
More area where?
Ground.
Ground.
More area means less pressure.
Okay, so how there is more area?
2 legs.
2 feet means,
More
so
area.
if 1 feet has an area of, like let's say 5 meters square, 2 feet will have 10 meters square, right? So 2 feet will have more area, and more area means less pressure, okay? That's how the questions will be asked, okay? It will not be asked directly. So numerous ways of asking questions. So please remember, this is the concept. If you know this, you will be able to answer any questions, okay? And now coming back to liquid pressure, I will show you the simulation here. Let me make it full screen. Are you able to see the last group?
Yes.
Okay. So here you will see some lot of terms here. So you have fluid density that I can control. As a default, they have made it water. I can make it honey and gasoline also, okay? And the density will be given here. Take a closed loop on this number, okay? And I can also control the gravity here. As a default, they have made it to Earth, where our gravity is
9.8.
okay? So I can move it to Mars and Jupiter also, and I can also calculate the pressure using this thing, okay? So if I bring it here, I can calculate the pressure at any surface, okay? Alright, so now let us begin with water here. I will keep as it is, and let me increase the flow. Okay, before that, what is the pressure here?
101.326.
101.326. What is that kPa? Yes?
Pascal.
Pascal. And K is kilo, right? Kilopascal. So by the way, the SI unit of pressure is Pascal. Okay, and right now it is kilopascal. So in Pascal, how much will this number be? Now kilogram to gram, you know, right? Now kilopascal to pascal. How many decimal place we need to move? 3 to the left or right? Right, okay. So if you, when you are converting bigger unit into smaller unit, the number will always be bigger, okay? So 1, 2, 3, so it will be 101.326 Pascal, okay? Now on the surface it is 101.326. So as I move down, just check what is happening to the number, okay? Let me keep it here. What is happening? It's becoming. So now it has become 102.094 kilopascal, okay? Now if I move again further down, it has become 115, right? 115 kilopascal. That's a rough number, okay? So what is happening? So pressure is directly related to what do you call that? Depth or the height, okay? So height of the pressure, I mean height of that liquid column is called as depth. So pressure is, let me do this. So pressure is directly proportional to. Now pressure is directly proportional to height. Okay. Okay, we have confirmed that. Let me turn on this water also. Now what is the pressure? 101.9, right? And if I go deep down, 112, 121, 127, 130, right? So pressure is increasing with the depth, right? Okay. Now let me change this water into something else, okay? Let me do the gasoline first, or the gasoline means your petrol, diesel, or any kerosene, okay? So at the surface, what is the pressure?
101.325.
101.325, okay. 101.325. And as I go down, okay, at this point it is 102.551, right? 102.551, okay. And what is the density of this gas?
700 kg per meter.
700
Kg per meter
cube. Now, looking at this unit, what is the equation for density? We are writing kg divided by meter cube, right? And this is the unit for density. Now, what is at the numerator?
Volume.
No, numerator.
Again, mass.
Kg, right? So kg is the SI unit of
Mass.
mass. So we write it as mass divided by
Volume.
meter cube is
Volume.
is volumes. This is how you remember the equations of any terms, okay? Just look at the units and you can, this is how you can derive the equation, okay? So in case if you forget in exam, you can just look at the SI units and then derive also, okay? Alright, so at this surface, for 700 kg per meter cube of density, the pressure is 102. So if I change it to water again, what is happening? The number increased to
103.
right? 103. For what is the free density of water? It is
1000.
actually, let me make it,
1000.
it is approximately 1000, okay? So 103 for 1000. Now if I again increase this to honey, it is becoming 103, right? Sorry, this is 103, which is for 1000. And let me, okay, go back to water. It was 103.097 and this is 103.7, right? 103.0 and 103.7. And what is the density of honey?
1420.
1420. So what relation can you see between density and pressure? This is
More the
density,
density,
this is
more the pressure.
So when density is 700, it is 102, right? When density was increased to 1000, it became 103. When density increased to 1420, it became 103.7. So as the density is increasing, the pressure is also increasing, right? So now we know that pressure is directly proportional to
Density.
density. Clear? Proved, right? Okay. And what thing we need to know, pressure is HT. Okay. Now this was all on Earth. Okay. Now let's move this entire thing to Mars now. Okay, I will make it water so that because water is very familiar for us. So the density of water on Earth is, oh no, not density, I mean the pressure. How much is it right now? 103.055. That is on Earth, okay? Now let's move this to Mars. Just look at what is happening to gravity at Mars, okay? So the gravity at Mars is 8, on Mars it is 3.7. And what is happening to density?
Decrease.
Decrease by so much, right? 103 to 39. So almost by how much? 40, 60, 63 something, right? Okay. And now let's move this to Jupiter. Okay, so on Jupiter the gravity is 24.9, right? 24.9. That is for Jupiter. And what is the density?
261.
261. Okay, you can get this. So as the acceleration due to gravity is increasing, what is happening to the pressure? It is also increasing. So we can say that pressure is directly proportional to gravity or the acceleration due to gravity, right? So we got three things from here. From this simulation, we know that pressure is directly proportional to height, pressure is directly proportional to density, and pressure is directly proportional to gravity. So we can combine all these three. Okay. And we can write this as pressure. Pressure is directly proportional to height, density, and gravity. So pressure, we can remove this proportionality sign and you can write it as equal to H rho G. Okay. So this is your main equation. Okay. There everyone. This is how we derive from the simulation. Okay. So pressure is directly proportional to height, pressure is directly proportional to density, and pressure is directly proportional to gravity. And don't forget the units, okay? The unit for pressure is Pascal and the symbol is PA, okay? And for height it will be meter. For density,
kg per meter cube.
density is mass over volume, so mass divided by volume, kg per meter cube, and gravity will be
Meter per second square.
because gravity is acceleration, so it will be meter per second square. Okay, don't forget. Now this was with the simulation. Okay, so now I will derive the same thing with maths and whatever you learn. Okay, now let's start with this one. So you know that density is mass divided by volume, right? Now how can you write mass? Just rearrange. Mass will be okay. So mass will be density multiplied by volume, right? Now again, now focus on volume now. So this kind of thing you might not have done. This is how we derive in maths and physics, okay? So how do we write volume? Now tell me a simple formula of volume that you learned in class 5, 6.
Length times width times height.
Okay. Length times
Feet.
breadth times
Height.
Okay. What is length times breadth?
Area.
Right? So we can write the volume as area multiplied by height, right? Here up to here? Okay. Now can we write mass as density multiplied by, so now what is our volume?
Area times
right?
height.
So area times height. So can we write mass like this? No? See, mass is density multiplied by volume, right? So our volume is area multiplied by height. So I'm just putting this here, okay? Here. So mass is density times area times height, right? Okay. Now the first equation, what did we learn? Pressure is the first one before this one.
Force
In terms of
divided by
force
area.
divided by force divided by
Area.
area. Now let's simplify force again. We are breaking everything down, okay? How do you write force?
Pressure times area.
Your basic definition of force. Newton's second law.
Mass times acceleration.
Mass times acceleration. And what is our acceleration here?
Gravity.
Gravity. So we can write force as mg, right? And divided by area. Now, what was our equation of mass that we got?
Pressure density times area times height.
Right? So we can write it as density times area times height times
Gravity.
gravity divided by
Area.
So this A and this A will get cancelled. We are left with
Rod.
rho
Hg.
which is equal to
Pressure.
Did we get the same thing?
Yes.
This is two ways of deriving the equation, okay? From the simulation, I have literally proved that it is working, and from mathematical point of view, this is how we derive, okay? You don't have to know how to derive, just know that pressure is rho Hg, okay? This much is fine. Just in case for extra information, if you are curious of how we got this is how we derive, okay? Clear? Any question? No? Is it confusing?
No,
sir.
Will you be able to derive?
Yes, sir.
Okay, good. Okay, so let me go back to my slides again. So this is how we write. Okay, so if you know pressure is force over area, you can calculate area, pressure and force, right? With these three equations. Okay. And we have done the simulation. And there are 3 laws of liquid pressure. You don't really have to know, but we have already derived, and I think you already know. So first law says pressure increases with increasing depth. You have proved that one, right?
Yes.
And the second law is pressure exerts equally in all directions. Okay? So let's say this is liquid here. Liquid will not just exert here, okay? It will exert here, 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 up, down, in all the directions, okay? Not just a particular direction. And the second one says the pressure increases as the density increases, right? We have already derived this. Okay. And I have shown you this one also and this one. So pressure is rho GH, rho is density, acceleration and height. Okay, and the unit is pressure. The unit is Pascal. Clear everyone? Yes? Okay. Now, as an activity, I will divide you into groups. Just some few calculations, okay, related to these topics. So remember your numbers, 1, 2, 3, 4, 5, 6, okay? And these are the questions. So this is what you can expect in this exam, okay? Somehow similar to this one. You can try solving. If you're done, you can raise your hand or say bingo. I will give you around 5 minutes because these are very simple questions, okay? And all you need to use is this equation. And you have already done this so many times before, so it should be easy by now. Okay? The last group, are you able to read?
Yes, sir.
Should I make it bigger or is it fine?
Fine, sir.
You just have to identify what number is which letter, okay? If you're able to do that, the answer is easy. Let's start with group number 1. And please listen to their answers because you need to know all the rest of the 5 questions, okay? You are the expert of your own question. Now focus on others. Go on, look at your answers now. For group number 1, anyone who would like to volunteer? And these are mathematical questions, but you can read. I will write to you. Why interest? Can you just explain also? No, you can't write like in simulations in exam. So like, let's see the exam question. How do you describe? Because I learned this in class, so you can write it. Anyone please help? So you said your answer Idris? Idris is correct. I just want to know like how do you explain? Anyone? You can sit. No, so what do you mean when it means they are like that was what I was looking for. Okay? That's how you get marks in the exam score. Okay, so what is the question? What is meant to pressure? So pressure is directly proportional to height of depth. Okay, this is how you write. Just this one and you write this. Thank you. So okay, it was a good answer. Pressure is equal to rho g h, and I was asking that density and gravity is constant. So if this is constant, if this is doubled, so P will be 2 rho g h. Rho g h is nu p, so P dash will be equal to 2p. The pressure will also be double if the density is double. Okay, this is how we write. Okay, good answer. Okay, let's go to the number 2. Okay, anyone? No, you can tell me the answer. You can just tell me and I will write. Okay, what things are given first?
Density is given, rho,
Which is
1000
1000.
kg meter per joule.
Okay, I will just ignore it.
And the height, 10 meters.
Height is 10.
And the pressure, we have to find pressure.
Pressure,
And about the acceleration, it's
everyone, if the acceleration due to gravity is not given in the question, you have to know that it is 9.8. Okay, it is a fixed number, it will never change. Okay, so acceleration due to gravity is 9.8. Now what do you do with these numbers?
We use the formula of P is equal rho GH.
So we are what are we doing? What we need to do is
We have to calculate. We have to find Pascal and pressure.
okay, what mathematical thing we need to do with these three numbers? Multiply. All we need to do is multiply these three numbers. Okay, so 1000 times 9.8 times 10. So what was your answer? 28,000. Okay, good answer. Thank you. And you don't forget to write the units. Okay.
Okay, sir.
Unit has also weightage in the exam. Okay. Question number 3 now. Anyone? So your question was pressure was given, density was given, and you were asked to find the height, right? So pressure is rho GH. So what is the equation of height? So your question was supposed to find, you were asked to find the height, right, or the depth. So from P is equal to rho GH, what is H? Okay, that is your answer, but in terms of letters, what is your P is rho GH, no? Now keep H on left hand side, check everything. How will it be?
P divided by
P divided by rho G. Okay? So this is how you write, okay? Height. So just moving the letters here and there, so it should be easy, okay? Don't get confused. Here it is multiplied, so when there is a multiplication, when you take it to the left hand side, it becomes division, okay? Pressure divided by rho G. And pressure was? So this is your height, 50,000. 50,000 divided by density is? Density is 1,000 multiplied by 9. How much do you get? 5.1. What's the unit? Meter, okay? Good. Good answer. So this is how we do it. Everything will be given to you, just one letter or one term will be missing. You just have to rearrange and find that one missing thing, okay?
okay, sir.
Great. Let's go to 4 now. Number 4, and it says, little bit different questions. Anyone? Two different liquids have densities 800 and 1000. Look at the questions, everyone. And if the column of each liquid has same height, which liquid will exert more pressure? You can just tell me.
There are two different liquids. We can keep the two different liquids, liquid A and liquid B.
Okay, wait. So we can write as liquid A and liquid B. Okay. So whenever you see this kind of question, just give the name yourself. Okay, A or B, 1 or 2. Say. Now,
And
what is the second step?
what
What do we know
we know the density
of liquid?
liquid
A is how much?
800,
Okay, A is 800.
B is 1000.
B is 1000.
In the question it says liquid A and B has the same density and gravity.
Same density. No, no. This is same density.
Same density. Height.
You don't get
Same height.
okay? Same height. So height and
Gravity.
gravity is same. Okay. And what is the only different thing here?
Density.
Density. So now we are asked to calculate what is the asking? Which will exert more pressure? Okay. Don't tell me the answer. Can everyone guess which will have more pressure? A or B? How do you know?
More density, more pressure. More
Directly proportional, right? And we have the height and gravity as same. Is that the answer? Okay. So pressure is, see here we do 800 multiplied by Hg, and here we are doing 1000 multiplied by Hg, okay? So our Hg and Hg is same here, so we can write this as a one term. So something multiplied by 1000 will be more than 800, right? So liquid B or the one which density is 1000 will have more pressure. Okay, good answer, thank you. Okay, so 0.5 now. So what is it asking? It's asking again pressure. Anyone? What are given?
Height
Which is
20 meters.
and
Rho is density is 1025.
and
Gravity is
gravity we take it as 9.8. Okay. So unless they tell you it is 10, you always take 9.8. Okay. And what do we do with these three numbers?
We multiply.
Multiply all these three numbers. So when you multiply 20 multiplied by 1000 multiplied by 9.8, you get how much go?
2,090.
200.
90.
900. This is in Pascal. I saw you were in kilopascal. How much will it be in kilopascal?
2,090.
So you divide this by.
90.
When you convert this to kilopascal, you divide this by 1000. Okay. So just take 3 decimal places. 1, 2, 3. That will be 200.9 kilopascal. Okay. Good answer. But you can give up to Pascal only. Okay. That's fine. Thank you. Okay, last group. Anyone? So what are you supposed to find? Gravity. Okay. So they are solving gravity. Okay. In reality, gravity is actually very difficult to solve. Okay. So they have solved. What did you answer?
The height is given.
Oh, okay. What thing is given?
The height is 15, the density is 980 km and kg per meter cube,
Okay.
and the pressure is 1,770, 147,000.
Okay. Can you just tell me the equation for gravity will be?
Gravity is equals pressure divided by density
Density and
and height times density.
That's 10 side 3. So when you divide, pressure was 1470001, and what was the density? 900 kg and it is 15. Okay, just okay, don't tell me the answer. Everyone, what should be the answer? Don't tell me. What should be the answer? 9.8. Okay, and roughly how much you got? 10. Okay, here we are getting 10. So you know your answer is correct because this question is on Earth. Okay? So you know that the gravity on Earth is 10 or 9.8. In case, like even I told them, in case you got the gravity as 4 or 20, you should know that your answer is wrong. Okay? So some fixed numbers, if you are asked to calculate, you should always get as 9.8 or approximately 10. Okay? Here everyone? Yes. Okay, everyone got the answer correct. So please, a lot of all you need to know about fluid pressure. We will learn other topics in the next class. Okay? Look at the applications. Okay, thank you everyone.
Thank you, sir.